Hi and welcome to my PlayHouse, and today I want to talk about RAID card and HBAs, host bus adapters. There are these two different ways to present the hard drives that you put in your server. Oh, bad example, no hard drives over here. Let's go over here. There's a lot of hard drives. There is two different ways to present those hard drives to the operating system, which is really what needs to see the hard drives in the server. There is the option of putting in a RAID card, this is a RAID card. This is a Hewlett-Packard P441 RAID card. What this does is that it sees some drives. You connect the drives here. In this case, they're external. It could also be internal drives, like, well, this one, which is another card. This one can handle a little bit more hard drives, even though it's really old compared to, but these connections are to drives that you actually connect in your servers. So this one can handle 16 drives in this one card, and it's also a RAID card. So what this does is that this is hardware based. It sees the drives and it presents you with, normally it's a GUO, and it presents you with options of how you want to present these drives to the operating system. So the RAID card is between the drives and the operating system. This means that you create a virtual drive on these RAID cards that is then presented to the operating system, where with an HBA, this is an HBA card, also with external connections. An HBA card gets the drives in. I believe this one can handle 1,024 drives. I'm not totally sure about that, but it's a big number. You need SAS expanders to do that, but it can be done. I'm using one for my experiment down here with the Hewlett-Packard box, which has 70 drives, or room for 70 drives, and it works on a card but similar to this one, almost the same as the Hewlett-Packard DAS down here. It has built-in SAS expanders. It just needs one cable to go down there for that to work. It does need two cables, but never mind. But the drives are being directly presented to the operating system without the controller, HBA controller, doing anything to them. So it finds the drives and it presents each drive to the operating system, and the operating system kind of handles the drives. Whereas with a RAID controller, well, the hardware RAID controller handles the drives and presents the operating system with a virtual drive. And this has some upsides and some downsides, and that was some of the stuff that I wanted to try and chat with you about. So I was planning to go do a bit of a drawing thing, so let's try that. So here is the setup. This is awesome. That's the HBA, and this is a RAID card, and I've even outlined it. I'm very proud. Where has this been all of my life? This is nice. There is differences in how this works, and there is pluses and there is minuses to this. HBA is relatively new, I think, compared to RAID. RAID card has been normal for quite a while in servers, whereas HBA is what you have seen in your PC, where you would have a disk controller and the disk controller would just present it to the operating system and you did whatever you needed to do in the operating system. Then at some point it started that you got, here it was something called a promise controller, and you would be able to kind of rate your disks inside this promise controller and make it RAID 0 and make it RAID 1 and stuff like that. So it was suddenly also available for the computers, and then they incorporated that into the system board as well, and it kind of looked like what you were used to as a RAID card in a server, but for regular PCs. On the server, on the other hand, RAID card is the good old daddy. Every server had a good RAID card, and then just lately HBAs has become a big thing. And so I'll try and write down some of the pluses and minuses as I see them. This is always debatable, so please in the comments below, let's just have a debate. Okay, I have listed some of the things that I'll try and talk about, and I might not be 100% right about this, so that's why we are discussing it in the comments below. Price. This is an HBA and this is the rate card, and the rate card is most likely the most expensive of the two, because HBA somehow is cheaper. You can also see there is fewer chips here, so it's simpler to just pass through the drives to the operating system as it is on the rate card, because a rate card, it needs to have a processor, it needs to have some RAM, it needs to have something with a BIOS and all good stuff. So yeah, this is cheaper, this is more expensive, but we will get back to the price, I'm sure. Performance, it also links back to price, because if you buy an HBA card for the same amount of money that you would use on a rate card, you would probably be able to afford a higher end HBA. Like this one is a 6 gigabits per second. I'm sure you could get a 12 gigabit for the same price as, or less than what a 6 gigabit rate card would cost. So you would be able to afford a better HBA card than rate card. But that said, performance wise, you have dedicated hardware over here managing your drives, and you can kind of think of the hard drives sitting here. We have each a disk here, and there can be many. And as soon as well, the operating system is at the other end, it's probably down here somewhere, and the operating system will ask for some data, or say deliver some data to the rate controller, and the rate controller, because this one has battery backup, it will be able to say right away, I got it, don't worry about it, and then it will send the data out to the disks afterwards, which from the operating system will be a lot faster than over here where you have the HBA. The operating system will have some data that it wants to send to the disks. We have the same, we have the disk sitting out here. Yeah, that's just the same amount. I just drawing here. That's SSDs or spinning disks, doesn't really matter. The operating system, let's just it's down here somewhere. We have an OS, and between that there is something to manage the file system, but that's all. That's a file system. Let's call it that, file system. Common one is ZFS, so that will have made some RAID setup. Let's say something called like a RAID 6 or equal. So the operating system will send it to the file system. The file system will split up the data to be used in a RAID 6 and then send the data to each drive out here. So this file has to be split up to, that's 4 drives is enough for RAID 6, so that would be okay. It will send a chunk to one drive, a chunk to the next drive, and each drive has to report back and tell you, we got it, we got it, we got it, we got it. So performance wise, my experience is that HBAs are not as fast as a RAID controller, and if it is, well, it takes away from the system power, because all of this happens in the CPU. The CPU is being bothered with this minor task of storing data, whereas over here the operating system, which sends the data to the RAID controller, and the RAID controller handles it, and the RAID controller has access to all these drives, and it caches the files that the operating system wants stored, and it handles all of that and communicates with the disks. When it has got the file and has told the operating system, I got it, well, no more processing power is being used down here, whereas the operating system tells the file system here that oh, there's a file to be stored, and the file system is using CPU cycles to communicate with the HBA, and the HBA has to talk to all the drives, and the drives report back through the HBA to the file system, and then the operating system will be told that, okay, we're done, everybody's happy. This is of course milliseconds, and with today's computers, which is also in the good old days, there was a reason why we purchased these more expensive RAID controllers, and a RAID controller can be really expensive. A good one with a lot of features can cost $1,000. Usually they're not that expensive, but a couple of $100 you should expect to pay for a RAID card. Whereas an HBA, you're probably down to $150 on those. A used, you can get an HBA card for $30 and a RAID controller for $50. The price for these used are not that great. So speed-wise, the RAID controller has an advantage because everything is handled in its own hardware, which is dedicated for this task. And it has some really fast cache memory on there as well that it can also utilize for that task. But that means that you have had to spend more money on it than over here with the HBA. Features, that's a little bit of a difficult one, because the HBA with the operating system, it has access to a lot of features, because this file system can be really advanced. Like ZFS can do a lot of good stuff for you, deduping and compression and encryption, and RAID 6, RAID 7, RAID, a lot of RAID things can be done software, but again, that will kill the performance of both the server and the speed. Where you on the RAID control are limited to fewer features, because the RAID control doesn't really know what data you are storing. It looks at the data in like blocks. It doesn't read the data. It's not able to see if this block is the same as this other block. It kind of knows which data you sometimes want to access, and it can preload those together. Sometimes with the file system and the operating system, it can determine that, well, if you read that file, you're probably going to be asking for that file next, so it can load that from the drives. But that can also happen over here. But these features, you pay more for them, and it's very normal to get a brand new good server, and it will come with a RAID controller, and you can only do RAID 0, 1 and JOB and just a bunch of disks. And then you're expected to pay extra for either you can have a little dongle that you need to put on there that will open up for some additional features, or you have to get an FOD, feature on demand code, which opens up for other features, which is a thing that I really hate about this, because you buy this more expensive RAID card and you have to pay extra for the features. They probably do this to get the price down, so it's not as far from this price on the HBA. They want the server system to be able to compete with other vendors, and therefore most of the features are taken off the RAID card, so you get a very minimum RAID card when you buy it, and then you have to buy features for it later when you find out that you're missing them, which is irritating. But features are fewer and expensive on RAID controllers, but that's where the RAID controller gets more of its performance, because calculating this RAID 6 over here, that takes performance, and you are now moving this performance out into this chip underneath here, and that handles that, and therefore it saves the operating system and the whole server system with handling that task. And therefore the features that you do get, they usually outperforms the features that you get over at the HBA, but you get them at a price. So this kind of makes sense. Features, better performance, speed, but price. Then we have redundancy. Both of the systems has redundancy. In here it's the operating system and the file system that makes sure that the drives out here is handled in a RAID 6. The card here, you can replace that and put in another one, and it will just continue seeing a RAID 6 out here. It's a little bit different if you take out a RAID card and put in another RAID card. You will have to import that RAID configuration. This is also a RAID 6, just that was an ugly R6. If you replace the card, you will have to tell the card that you are supposed to see these drives as a RAID 6. It helps a little bit if it's actually one of the drives that fails. If this drive fails, I have a red marker. If this drive fails, well, the RAID card knows that, oh, I have a drive out here. It has failed. It was supposed to deliver data, and it's not doing anything right now. So it can give me an error. The RAID card can tell the operating system that it has a drive error, and actually also the RAID card can tell the management system of the server that we have a broken disk, and the management system in a server, like on Lenovo it's the IMM, on HP it's the ILO, and yeah, on Dell is it called the DAC or something like that. And that system will be able to send an email out and tell me that that drive has died. Doesn't work as well with the HBA as far as I know. I have not seen an HBA be able to do that because it doesn't communicate with the IMM. I'm not totally sure about this, but if a drive dies over here, it's the operating system that will, or file system here, that will know that something is wrong. I might be wrong about that. It might actually also be in the IMM, especially if you actually get. Oh, that might be to be determined. I have never actually had a server with an HBA. I do have one, but it's not being used as such. But if this drive fails and in the HBA, it's the file system that will handle that. So when I come and I replace that drive, I'm gonna remove this drive here and I pop in a new one. I come and I pop in a new one. Nothing will happen. When I do that, I will have to go and fix over here and tell it that new drive, use that one. Whereas if I replace this one, come in and put a new one in, the RAID controller will know instantly that I took out a drive, and that drive that I put in will then replace the drive that failed, and it will instantly start doing the work internally here and do the RAID 6 configuration. It will read the other drives and it will put its part of the RAID 6 configuration out to this drive, and it's not gonna bother the operating system with this task. Whereas if it happens over here, it will be the file system on the same system as the operating system that is going to be handling this. On a modern server, I'm sure it's not going to be much of a drag on the system, but it is a drag on the system in some small amount. Security. Yeah, we're going to make a little scenario. We don't need that anymore. Yeah. If the operating system is writing a file, big file, to the disks out here, and the power cuts, what will happen? This is a potential danger because the operating system has this file in memory that it's writing. So this is kind of a drag on the operating system because as it knows that it's dealing directly with the disks out here. So the operating system will have to let's say that this file is something that we have generated in an editing program, and we are now rendering out our file, and it's gonna be storing that to disks. And if the power cuts in the middle of that, it will be in the middle of writing that data. So to use an example that will work here, this is a database server. We are transferring a lot of money forth and back over the globe, and this database controls that. So these transactions come in and come out. This is, let's say it's the stock market, and I'm buying and selling stocks, and if the power cuts here, it's very important to get every single itchy bitchy transaction from the operating system to the file system, to the card, to the hard drives, so that when power returns, those 60 million Intel stocks that I just got rid of, it's very important that I also get the money for those. In that regard, it's not very good to use an HBA, because the operating system, it will be able to tell the file system that we have some data very important, but the file system is not going to be able to diddly squat with it if the power goes, and so it has to hurry up and write it to the HBA, but the HBA is not able to handle any data if the power goes. So whatever data was in the operating system will die here. Whatever data the file system had received will die. Whatever data was on the way through the HBA will die. Only the data that reached the drives out here will be valid, which is probably okay for most cases if the program here is set to really make sure that this data is actually secured before Morten gets his money for his Intel stocks. Over at the RAID controller, you have some more security. The operating system will be able to throw that data over to the RAID card, and the RAID card will say immediately, I got the data. And the RAID card will, with the battery backup, it will have that data in cache, and it will be doing the writing out to the drives. If this crashes in the middle of that, the RAID card, this battery will normally last 72 hours. And there's a reason why it's 72 hours. It's meant so that 72 hours, this can crash on a Friday, and you will still have a couple of days next week to get your data out before that data becomes lost. So with important data on databases, I think RAID card is a must-have compared to HBAs, because a database is really good at getting corrupt. There are of course ways of ensuring that in the database system and the operating system and all of that, but it's more likely to get corrupt than if you have security on the RAID controller. What will happen when you repower the server system? Let's just say it crashed for some other reason. As soon as it gets power back, it will continue where it left off. It will see, I have data in cache, I need to throw that out to the drives. And it will do that all by itself. Most likely even before the system is booted, it will recognize that and throw the data out, and it will boot the operating system, and everything will look as if nothing happened. Where this might actually be a different case, because it was in the middle of writing to this database. It only got to write the RAID 6 data to these 3 drives. There could be some security that will make sure that, oh, we didn't get to write all that to that, but that will only be determined when the operating system is back online. And the database is gonna be trying to fix that. So yeah, so the HBAs has been growing in popularity because of software RAID, which this is software RAID, which is widely used in FreeNAS, Linux, and you know, lots of drives, many hard drives. So that has become very popular for those sort of things on RAID. Also a Linux distribution. It's very much as if Linux you get these cards, but there's not always a Linux driver for the RAID card. You might not be able to get a Linux driver for this RAID card. You might be able to get one for Red Hat. You might not be able to get it for Debian or something like that. So instead of having the trouble with the driver, the Linux world has more or less just gone ahead and said, well, we're just going to be using HBA, and we have our own software solution underneath, which is often this ZFS system that handles all the drives. And marvelous. And this is also often in the environments where you for home use, where you don't want to spend a lot of money, and spending like, well, $500 on a good RAID controller, well, you could get a lot of interesting storage drives for that money instead. So software RAID is really good for optimizing the amount of features and stuff that you get, and ZFS is great because that is also free. So all of this is for the, well, free stuff, right? You don't actually have to pay for it. Well, maybe unless on RAID down here, there is a little bit of a price tag on that. It's not very expensive, but you pay a little bit. Whereas this is more like high-end stuff. This is more enterprise than this. Even though you often see HBAs when you have a very large amount of drives. If I have 1,000 drives, HBA could be used, but it's more or less just because the RAID controller that will be able to handle 1,000 drives would be very expensive, even though it's really not. I believe this one can handle 512 drives, so 2 of those and you have 1,000 drives. And yeah, so actually if you look in a really new and modern SAN solution, I have had a chance to look inside an EMC storage box with some really high performance flash drives out in front, and that was actually, there was a very high performance server in there with 2 dedicated CPUs and RAM and everything to handle 8 drives out in front of the box. Those 8 drives went to a server, and then that server would be hooked up on the network. And so that whole server kind of did what the RAID controller used to do, just it used HBA technology instead, where the server did all the work, and they battery backed up the whole server instead of using a RAID controller. It's kind of weird. It was kind of hyper-converged storage on the next level. Really weird. 8 drives and a 2 CPU server to handle that. Yeah, okay, it was some big, it was like 7 point something terabyte flash drives that was in there, but very expensive stuff. And kind of a server like that, just to control that, it was like a 5U box, and there was like 4 blades in the back of that, and each of them was this server with 2 CPUs and RAM, and that then handled 8 drives on the front of it. I'm sure it had a lot of I/O, but yeah, that was kind of my rant on HBAs and RAID card. It's definitely open for debate, because I'm sure I missed something, or you're not seeing it the same way as me. So do go tell me where I'm wrong, or if I'm right. Happens too, you know. So yeah, please give this video a like, hit that bell thingy, and well, join me over at Twitter. I tweet out random stuff all the time. So yeah, thank you very much for watching my videos. Do subscribe to my channel so that you can see me again, and have a really nice day. Bye bye.